We have learned that a normal distribution is determined by its mean, which is also mu, and standard deviation, which is also sigma. For a normal distribution, we can have different mean, we can have different standard deviation. So basically, we have unlimited number of combination of different mu's and different sigmas. So we have all kinds of normal distributions. In order to calculate the probability of distributions, of normal distributions, there are basically two methods. One, we use calculus. Basically, we use this formula here. Okay, we saw this before, all right? And we calculate the probabilities of normal distribution by taking the integrals of this fx here. Using this method take quite some time. So each time we have to calculate the integrals, and it's inconvenient in field use. So in this course, we're not gonna use this method. What we will do is we will use the second method, which is we use tables for normal distributions. Each time we need to find the probabilities, we look up the table. The advantage is it's very easy to use, it's convenient for field use. The challenge is we know there's many different kind of normal distributions. For each specific normal distribution, we need to have a specific table. So end of the day, we will have a lot of normal distribution tables. That's not convenient either. So the solution is we're going to have a standard normal distribution table, and we will use this standard normal distribution table to solve the probabilities of all kinds of normal distributions. In this session, we will focus on standard normal distribution table. In the next session, we will learn how to use the standard normal distribution table to solve probabilities of all other different kind of normal distributions. Here's the general procedure for finding normal probabilities. For probability of x bigger than a, smaller than b. Notice that x here does not have to be a standard normal distribution. Recall that when we use standard normal distribution, that is a variable z, here x is just any normal distribution. Now, this normal distribution has a mean mu and a standard deviation sigma. There are 3 steps to calculate this probability. Step 1, draw the normal curve for the problem in terms of x. In other words, for example, we try to find the probability of x bigger than a, smaller than b. What we do is we draw a curve here in the bottom, if you can see that, and then we draw a curve, okay, and then we highlight an area that is what we're looking for, which is probability of x bigger than, smaller than b. That's step 1. Now step 2, we translate the x value to z value. Use this formula. Z equals to x minus mu divided by sigma, and this mu comes from here. Okay, which is the mean of the normal distribution, divided, this is z, divided by standard deviation, which is this one, which is this standard deviation. The value of this standard deviation comes from the standard deviation of the normal distribution x. Okay, we're going to show you an example. Step 3, use the standardized normal distribution table. Okay, so it's very simple, 3 steps. Now here comes the first example. Let x represent the time it takes in seconds to download an image file from the internet. Suppose x is a normal distribution with a mean of 18 seconds and a standard deviation of 5.0 seconds. We try to find a probability x smaller than 18.6. So step 1, we draw the normal curve of the problem in terms of x. So here first, the normal distribution curve looks like this, with a mean in the middle is 18. And we try to find the probability of x smaller than 18.6, so goes from 18.6 all the way to the left. The highlighted area is probability of x smaller than 18.6. Now step 2, we translate the x value to z values. So we're going to use the formula here, z equals to x minus mu divided by sigma. So since we know x it's a normal distribution, it has mu equals to 18.0, sigma equals to 5, and we're looking for the value of probability x smaller than 18.6. Here's the formula. So let's plug in the numbers to the formula. X is 18.6. We plug it in here. Mu is 18.0. Plug it in here. Sigma is 5. We plug it in here. So we got a z value equals to this, which is 0.12. This is step 2. Now we have translated the x value to z values, and we know that the z equals to 0.12. What happens is here is the original normal distribution with mu equals to 18, sigma equals to 5. Now we can transform that to the standard normal distribution. And here is a 0. Now, we find the z value is 0.12 here. So that is here. In the standard normal distribution, we find 0.12 here. So the highlighted area here in red here is exactly same as the highlighted area here. And that's the magic. So what you need to remember is we can translate x value to z value. So x is smaller than 18.6. The probability here highlighted equals to the probability here in the standard normal distribution, which is probability of z smaller than 0.12. So the value of this two equals. And that's how we're going to calculate the probability of this. Okay? Now, the probability of x smaller than 18.6 equals to probability of z smaller than 0.12. And it's easy for us to calculate z smaller than 0.12, right? So basically, we find 0.1 in the first column in the normal distribution table, standardized normal distribution table. 0.1 here, 0.02 here, find the value, 0.5478. And that is the probability highlighted here, which is 0.5478. This value is also the value of probability of x smaller than 18.6. Now, please stop this online section now and do an in-class exercise. Here is the exercise. Basically, mean equals to 7 seconds. Standard deviation equals to 2 seconds. We'll try to find the probability of x is smaller than 9. Now, you need to stop this online session right now and finish this in-class exercise before you go forward. So let's go ahead and bring out a piece of paper and a pen, and let's work out this one. All right, are you done yet? So here comes the solution of in-class exercise 1. Step 1, draw the normal curve for the problem in terms of x. So the problem is probability of x smaller than 9, and we know that the mean equals to 7, and 9 is here. We draw it, highlight this area under the curve above the x-axis. And the area highlighted in red is what we're trying to find out. Step 2, we translate the x value to z value. So z equals to x minus mu divided by sigma. Following our example 1, we plug in the numbers. X equals to 9 here. Mu equals to 7 here, which we know. And the sigma equals to 5. All these three values is what we know already. And this equals to 1. Step 3, we use the standardized normal distribution table. And you're going to find that the probability of x smaller than 9, we translate that into probability of z smaller than 1. And it equals to 0.8413. That is the value of this. Now let's look at another example. Let x represent the time it takes in seconds to download the image from the internet. Suppose x is normal with a mean of 18 seconds and a standard deviation of 5 seconds. We try to find the probability of x bigger than 18.6. Again, same 3 steps. Step 1, draw the normal curve for the problem in terms of x. So we're trying to find the probability of x bigger than 18.6, and the middle is here, which is the mu equals 18. So bigger than 18.6 is the highlighted area here. Step 2, as we know, x is normal with mu equals to 18.0, sigma equals to 5.0. We want to find out the probability of x bigger than 18.6. So we need to translate the x value to z value. Here's the formula. Z equals to x minus mu divided by sigma. We'll plug in numbers. We plug in 18.6 to here, 18 to here, 5 to here. This value comes from here. All right. We finish the calculation of this. We get 0.12. Now, here's the step 3. We use the standardized normal distribution table to find the probability of z smaller than 0.12 first. As we've done, 0.1 is here, 0.02 is here in the standardized normal distribution table. The value is 0.5478. And that is the size of this area, highlighted area. That is probability of z smaller than 0.12, which is the value is this. Now, we actually trying to find probability of x bigger than 18.6, which equals to probability of z bigger than 0.12. All right. And we know that probability of z bigger than 0.12 equals to 1 minus probability of z smaller than 0.12. Okay, that's what we've learned in the last week's sessions. Now, we know probability of z smaller than 0.12 equals to 0.5478. So 1 minus this is the value we're looking for. It is 0.4522. And that is this area we're looking for. And that is the value. Here comes our in-class exercise 2. Again, we have a normal distribution x mean equals to 7, standard deviation equals to 2. We're trying to find probability of x bigger than 9. Now, again, this is a very important exercise, so please stop this session and try to solve this in-class exercise, taking as much time as you need. Alright, I assume that you have done this in-class exercise too, so let's take a look at this solution together. Step 1, we're going to draw the normal curve for the problem in terms of x. I assume that you can do that right now, so I'm not going to draw it here again. Step 2, we translate the x value to z values, so z equals to x minus mu divided by sigma, plug in numbers, equals to 1. Now, we use the standardized normal distribution table. We know x bigger than 9 equals to probability of z bigger than 1 and equals to probability 1 minus probability of z smaller than 1, which equals to 1 minus 0.8413, equals to 0.587. This is actually same as our example 2. So hopefully you feel comfortable with this now. One more example. We now try to find a normal probability between two values. So again, x has as a normal distribution with mean equals to 18, standard deviation equals to 5. We're trying to find the probability of x bigger than 18 and smaller than 18.6. Now, step 1, we draw the normal distribution curve for the problem in terms of x, which is here. Probability of x bigger than 18, smaller than 18.6. So 18 is here, 18.6 is here. This is the highlighted area is what we're trying to look, the size of this area is what we're trying to find out. Okay, so it's going to be probability of x bigger than 18, smaller than 18.6 is the size of this highlighted area. Now we're trying to find out the probability of x is bigger than 18, smaller than 18.6. So we have two values, two x values here, x and it's 18 and 18.6, two values here. So we're going to calculate the two z values. First one, z equals to x minus mu divided by sigma, but we plug in 18 from here. And we know mu equals to 18 and the sigma equals to 5. X is from here, so the z value is 0. The second z value here is this one. That's for 18.6. X equals to 18.6, mu 18, sigma equals to 5. We finish the calculation. It's 0.12. Now our job is to, in order to find out this value, probability of x bigger than 18 and smaller than 18.6, we only need to find out this value, which is z bigger than 0 and smaller than 0.12. That's what we're trying to find out. So here's the area. And notice here's a 0, here's a 0.12, and it is on a standardized normal distribution now. Now we know that in order to find out the probability of x bigger than 18, smaller than 18.6, we only need to find out probability of z bigger than 0 and smaller than 0.12. So this value, as we learned before, probability of z bigger than 0, smaller than 0.12 equals to probability of z smaller than 0.12 minus probability of z smaller than 0. So from the normal distribution table, we find out that the probability of z smaller than 0.12 equals to 0.5478. From the table, this table here, normal distribution table, we can also find out the probability of z smaller than 0 equals to 0.5. So we plug in these two numbers. we got 0.0478. And that is the size of this highlighted area. And this part is probability of z smaller than 0, and this part is probability of z smaller than 0.12. So this is the highlighted area. And the size of it is 0.0478. And we're done. We know this is also the size of probability of x bigger than 18, smaller than 18.6.